In the vast silent theater of space, a story unfolded nearly 50 years ago. Two golden records were launched aboard the Voyager spacecraft, carrying the sounds and images of our world. They were messages in a cosmic bottle tossed into an ocean of stars, intended for any intelligent life that might find them. These records carry greetings in 55 languages, the music of Bach and Chuck Berry, and the brainwaves of a woman in love. Imagine that for a moment. A piece of our humanity, our art, our very thoughts, hurtling through the void at thousands of miles per hour. It's a profound act of hope, a whisper into the immense darkness, a testament to our deep-seated need to connect and understand what lies beyond our small blue world. This journey of the golden record is more than just a scientific mission. It's a poetic gesture. It speaks to our fundamental curiosity about the universe. Are we alone? What other wonders are out there waiting to be discovered? These questions have driven humanity since we first looked up at the night sky. We've always been explorers, whether crossing oceans or charting the heavens. The Voyager probes, now in interstellar space, are the farthest human-made objects from Earth. They are our silent ambassadors, carrying a piece of our soul into the great unknown, a journey that might last for 1 billion years. What cosmic phenomena will they witness on their endless voyage? What secrets will they pass by in the dark? The universe, in its infinite expanse, is filled with objects and events that defy our everyday logic and imagination. We live on a quiet planetary island, but just beyond our shores lie cosmic storms and celestial monsters that dwarf anything we can conceive. We send out these tiny probes, these whispers of our existence, hoping to learn more about this grand, mysterious place we call home. We are searching for answers to questions we are only just beginning to formulate. The golden record is not just a message for aliens, it is a message for ourselves, a reminder of how small we are and how much there is still left to learn about the cosmos. This quest for knowledge is what fuels our fascination with space. It leads us to ponder the most extreme, the most bizarre, and the most powerful objects in existence. We are drawn to the edges of understanding, to the places where our theories break down and our minds are forced to expand. The story of the Voyager probes is the story of humanity's reach exceeding its grasp, a beautiful and humbling admission that we are just beginning to scratch the surface of cosmic reality. It's a journey that takes us from the familiar sounds of our world to the very edge of the weirdest phenomena the universe has to offer. When we talk about cosmic strangeness, one object almost always steals the show: the black hole. But what is a black hole, really? Imagine a star many times more massive than our own sun. For millions of years it burns brightly, a furnace of nuclear fusion. But eventually, its fuel runs out, the star collapses under its own immense gravity, squeezing all of its matter down into an impossibly small point. This point is called a singularity. The gravity here is so powerful, so overwhelmingly strong, that nothing, not even light itself, can escape its pull. A black hole is born. It's not a hole in the traditional sense, but rather a colossal amount of matter packed into a tiny space. Think of it like this. If you squeezed the entire Earth down to the size of a marble, you would create a black hole. Its gravitational pull would be immense, but it would still have the same mass as our planet. Now imagine doing that with a star 100 times bigger than our sun. The result is a region of space-time so warped and twisted that it becomes a one-way street. Anything that crosses its boundary, the event horizon, is lost forever. It's the ultimate point of no return. This is why we can't see black holes directly. They swallow all light. We can only detect them by observing their effects on nearby stars and gas, which get whipped around in a frantic dance before being pulled in. The idea of a black hole bends our minds because it breaks the rules of our everyday experience. Time itself behaves strangely near a black hole. If you could watch a friend fall into one from a safe distance, you would see them slow down as they approached the event horizon. Their movements would become slower and slower until they appeared to freeze in place, fading away over an eternity. But for your friend, time would pass normally as they crossed the boundary, only to be stretched and torn apart by the incredible gravitational forces inside. This stretching effect is poetically called spaghettification. It's a concept that sounds like science fiction, but it is a real prediction of Einstein's theory of general relativity, so it is no wonder that black holes have captured our imagination and earned their reputation as the weirdest things in the universe. They are invisible monsters that eat light and warp time. They are the final dark victory of gravity over all other forces. They represent a frontier of physics where our current understanding comes to a halt. When we look at a black hole, we are staring into an abyss of pure mystery, a place where the laws of the universe as we know them may no longer apply. They are the ultimate cosmic enigma, the final word in celestial horror stories whispered around the campfire of science. We have placed the black hole on a pedestal, crowning it the king of cosmic weirdness. It is a title that seems well-deserved. An object that devours light, bends time, and possesses infinite density is certainly a strong contender. For decades, these celestial phantoms have dominated our discussions about the extremes of the universe. They are the villains in our space operas, and the ultimate puzzles for our brightest physicists. Their very existence challenges our fundamental understanding of reality. But is it possible that our fascination has created a blind spot? Could our focus on black holes be preventing us from seeing other, perhaps even stranger things lurking in the cosmic shadows? Let's pause and ask ourselves a simple question. What makes something strange? Is it just about being extreme? Or is it about being unexpected, defying our predictions in a way that forces us to rewrite our textbooks? Black holes, for all their bizarreness, are actually a natural and expected outcome of our best theory of gravity, Einstein's general relativity. In a way, the universe would be stranger if black holes didn't exist. Their presence confirms that our understanding of gravity is, at least in this regard, on the right track. So, while they are undeniably extreme, their existence is not entirely a surprise to modern physics. Perhaps true strangeness lies not in the things we can predict, however wild they may be, but in the things that make us say, now, how is that even possible? The universe is a vast and creative place, and it may have cooked up objects and phenomena that are far more peculiar than a simple gravitational collapse. What if there are things out there that challenge not just our sense of scale, but our very understanding of matter, energy, and the fundamental forces of nature? Are we so captivated by the dramatic pull of the black hole that we are ignoring the subtle whispers of other equally bizarre cosmic players? This is the moment to broaden our perspective. Let's step back from the event horizon and scan the rest of the cosmic landscape. The universe is not a one-act play starring the black hole. It is a grand, sprawling epic with a huge cast of characters, each with its own unique and bewildering story. By fixating on one cosmic celebrity, we might be missing out on the rich tapestry of weirdness that fills the cosmos. It's time to explore the underdogs, the unsung heroes of strangeness. What other contenders are out there vying for the title of the strangest thing in space? I think you might be surprised. Let's begin our tour of cosmic oddities with an object that sounds like it was plucked from a fairy tale, a white dwarf. When a star like our Sun reaches the end of its life, it doesn't have enough mass to become a black hole. Instead, after puffing off its outer layers to create a beautiful planetary nebula, its core collapses into a super-dense object about the size of Earth. This is a white dwarf. It's the cooling, dying ember of a once mighty star. A single teaspoon of its material would weigh as much as an elephant on Earth, around 5 tons. This incredible density is the first clue that we are dealing with something truly unusual. But the story gets stranger. The immense pressure inside a white dwarf does something remarkable to the carbon and oxygen atoms that make up its core. It crushes them together so intensely that they are forced into a crystal lattice structure. In other words, the heart of the star crystallizes. For a carbon-rich white dwarf, this means its core is, for all intents and purposes, a diamond. Not a small one either. We are talking about a planet-sized diamond. Astronomers have found one such star named BPM 37093, which they nicknamed Lucy after the Beatles' song Lucy in the Sky with Diamonds. It is a 10 billion trillion carat diamond floating silently in space. Now, how does this compare to a black hole? A black hole is a singularity, a point of infinite density. A white dwarf is only incredibly dense, not infinitely so. A black hole swallows everything, while a white dwarf just sits there, slowly cooling over trillions of years until it becomes a cold, dark black dwarf. On the surface, the black hole seems stranger. But think about it this way. A black hole is an object of pure gravity, a rupture in space-time. A crystallized white dwarf, on the other hand, is an object made of matter we understand, carbon, behaving in a way that is utterly alien to our experience. It's a mountain-sized diamond forged in a star's heart. Is a planet of diamonds stranger than a hole in reality? The black hole is a concept, a mathematical extreme. The diamond star is a physical object, a celestial jewel of unimaginable size and value. It takes something we consider precious and rare on Earth and presents it on a scale that is almost comical in its grandeur. It challenges our sense of value and scale. While a black hole inspires a sense of cosmic dread, a white dwarf star with a diamond heart inspires a sense of cosmic wonder and absurdity. Which is truly stranger, an object of pure destructive force, or a universe that creates jewels the size of worlds? Section 5, the universe's most powerful magnets. You know, if a white dwarf is the dense ember of a sun-like star, then our next object is, the even more extreme remnant of a much larger star. Meet the neutron star. When a star between about 10 and 25 times the mass of our sun explodes in a supernova, its core collapses with even greater force than that which creates a white dwarf. The gravity is so intense that it crushes protons and electrons together to form neutrons. The result is an object only about 12 miles across, the size of a city, but with more mass than our entire sun. Imagine this, a single sugar cube-sized piece of a neutron star would weigh 100 million tons. It's so dense that if you dropped a marshmallow on it, it would hit the surface with the force of an atomic bomb. But hey, we are here to talk about the strangest things, right? And while neutron stars are very strange, a special type of them takes weirdness to a whole new level, the magnetar. As the name suggests, a magnetar is all about magnetism. Through processes we still don't fully understand, some young neutron stars develop magnetic fields that are astonishingly powerful. We're talking about 1,000 trillion times stronger than the Earth's magnetic field. This is a magnetic field so intense that it would be lethal from 100,000 miles away, capable of wiping the data from every credit card on Earth from halfway to the moon. This colossal magnetic field causes the magnetar's crust to be under incredible stress. Occasionally, the crust cracks, causing a starquake. These events release enormous bursts of energy, mostly in the form of X-rays and gamma rays. In 2004, a starquake on a magnetar named SGR 1806-20 released more energy in 1/10 of a second than our sun has emitted in the last 100,000 years. This burst of energy was so powerful that it physically affected Earth's upper atmosphere, even though the magnetar was 50,000 light-years away. It's an object with a temper, capable of throwing a tantrum that can be felt across the galaxy. So let's pit the magnetar against the black hole. A black hole's power comes from gravity, a force that pulls things in. A magnetar's power comes from magnetism, a force that can push and pull and unleash energy blasts of unimaginable scale. A black hole is a silent, passive trap. A magnetar is an active, violent monster. While you have to get very close to a black hole to be in danger, a magnetar can reach out and touch you from an incredible distance. Which is stranger, the quiet void that swallows light, or the tiny, city-sized star whose magnetic rage can shake the galaxy? The black hole is an absence, while the magnetar is a terrifying presence. Our solar system feels like a neat and tidy place. Planets orbit a central star in a predictable, stable dance. This is the model we've grown up with, the image of a cosmic family. But the universe is not always so orderly. In the chaotic process of star system formation or through later gravitational encounters, planets can be violently ejected from their home systems. They are flung out into the vast empty space between the stars, destined to wander the galaxy alone for eternity. These are the rogue planets, the cosmic orphans. They have no sun to warm them, no star to orbit. They are adrift in the cold interstellar darkness. Detecting these lonely worlds is incredibly difficult. They don't shine with their own light, and there is no parent star whose light they can block. So how do we find them? We use a clever technique called gravitational microlensing. When a rogue planet happens to pass almost directly in front of a distant star from our point of view, its gravity acts like a lens, briefly magnifying the star's light. It's a tiny, fleeting signal, and it tells us that an unseen object has drifted by. Based on these brief detections, astronomers estimate there could be billions or even trillions of rogue planets in our Milky Way galaxy alone. They might outnumber the stars themselves. What would life on such a world be like? With no sun, the surface would be frozen solid, a world of perpetual night and unimaginable cold. But that might not be the end of the story. If a rogue planet is large enough, like a gas giant, it could have large moons. The immense gravitational pull of the planet could knead the interiors of these moons, generating heat through tidal forces, much like Jupiter does for its moon Europa. This could potentially keep a liquid water ocean warm beneath a thick shell of ice. In this eternal darkness, life could theoretically exist, powered not by sunlight but by chemical energy from hydrothermal vents, a whole ecosystem in a place with no day. Comparing a rogue planet to a black hole is a study in contrasts. A black hole is a point of extreme physics, a place of immense power and violence. A rogue planet is defined by its profound loneliness and isolation. Its strangeness isn't about breaking the laws of physics, but about challenging our idea of what a world is. Can a planet exist without a sun? Can there be life in total darkness? A black hole is strange because of what it is. A rogue planet is strange because of what it isn't. It isn't part of a family, it isn't bathed in starlight, it isn't home in the way we understand it. It's the ultimate symbol of cosmic solitude, a world without a sky. So far we have discussed strange objects made of matter. We can in principle understand carbon, neutrons, rocks and gas. But our final contender for the strangest thing in space is something else entirely. It's something we cannot see, cannot touch, and cannot detect directly at all. Yet we believe it makes up about 85% of all the matter in the universe. We call it dark matter. The name itself speaks volumes about its mystery. We know it exists not because we can see it, but because we can see its gravitational effects on the things we can see. It is the ghost in the cosmic machine. The evidence for dark matter is overwhelming. When we look at galaxies, we see that the stars on the outer edges are rotating far too quickly. According to our understanding of gravity, they should be flying off into space like children flung from a merry-go-round that is spinning too fast. The only way they can be held in place is if there is a huge amount of extra, unseen mass providing the necessary gravitational glue. This invisible mass is dark matter. We see its effects everywhere, in the way galaxies cluster together, in the way light from distant objects is bent as it travels through space. Dark matter forms a vast, invisible scaffolding upon which the entire visible universe is built. So, what is it? That is the trillion-dollar question. We know what it isn't. It isn't just dark clouds of normal matter, because we would be able to detect them in other ways. It isn't black holes because we don't see enough of the telltale gravitational lensing events that they would cause. It has to be some kind of new, exotic particle that doesn't interact with light or any other form of electromagnetic radiation. Scientists around the world are running massive experiments deep underground, shielded from cosmic rays, trying to catch a fleeting glimpse of a dark matter particle bouncing off a normal atom. So far, they have found nothing. Compared to a black hole, the strangeness of dark matter is of a completely different order. A black hole is an extreme manifestation of gravity and matter as we know them. Dark matter suggests that our entire inventory of the universe's building blocks is fundamentally incomplete. It's not just one weird object, it's the dominant form of matter in the cosmos, and we have absolutely no idea what it is. It's like trying to understand a city when you can only see the streetlights, completely unaware of the buildings, roads and people that make up the vast majority of the city. The black hole is a known unknown. Dark matter is an unknown unknown. We have journeyed through a gallery of cosmic curiosities. We have seen the diamond heart of a dead star, a celestial jewel the size of a planet. We have faced the ferocious magnetic rage of a magnetar, a tiny object with the power to shake the galaxy. We have drifted through the cold darkness with a rogue planet, a world forever lost in the interstellar night, and we have contemplated the invisible ocean of dark matter that constitutes the very foundation of the cosmos. Now we must return to our original question. Are black holes truly the strangest things in space? It's time to put them all side by side in a cosmic contest of strangeness. On one side, we have the black hole. Its claim to the title is strong. It is a rupture in the fabric of reality, a place where time and space are warped to their absolute limits. It is the ultimate abyss, a one-way door to a fate we cannot comprehend. Its strangeness is conceptual, a product of extreme physics that challenges our most basic intuitions about the world. The black hole represents a finality, an endpoint of matter and information that fills us with a kind of philosophical dread. It is the undisputed champion of gravitational weirdness, a perfect and terrifying monster. On the other side, we have our challengers. The diamond star is strange because of its sheer, ludicrous extravagance. It takes a familiar substance and scales it up to a cosmic level, creating an object of absurd beauty and value. The magnetar is strange because of its violent, active power. It is a tiny dynamo of fury, a testament to the power of magnetism, a force we often take for granted. The rogue planet is strange because of its profound loneliness and the possibilities for life in eternal darkness. And dark matter? Well, dark matter is strange because it forces us to admit our own ignorance on a cosmic scale. So what do you think is the weirdest object in the universe? Is it the perfect, predictable monster that is the black hole? Or is it the unexpected oddity like a planet-sized diamond? Is it the object that destroys, or the object that creates in bizarre ways? Perhaps the answer depends on your definition of strange. If strangeness is about raw, concentrated power and the bending of physical laws, the black hole probably wins. But if strangeness is about surprise, about the universe's capacity to create things we never would have imagined, then the title is very much up for grabs. The universe, it seems, is a far more creative and diverse place than we often give it credit for. Our cosmic journey is drawing to a close, but the real journey of discovery is just beginning. We started with the black hole, the long-reigning king of cosmic strangeness. And while its title is formidable, we have seen that the universe holds a menagerie of other contenders, each bizarre and wonderful in its own right. From diamond stars and magnetic titans to lonely worlds and invisible matter, the cosmos is filled with phenomena that stretch the limits of our imagination. The black hole may be the most famous monster, but it is far from the only one in the deep. What this tour teaches us is that the universe is not just strange. It is strange in countless different ways. There is the strangeness of scale, the strangeness of power, the strangeness of isolation, and the strangeness of pure mystery. Each new discovery does not just add a new fact to our collection, it reveals a new dimension of weirdness, a new way in which reality can be twisted and formed. The more we learn, the more we realize how little we truly know. Our greatest discoveries often lie in finding out that we had the wrong questions all along. The universe is not just stranger than we imagine, it is stranger than we can imagine. This is not a cause for despair, but a reason for profound excitement and hope. It means that there are endless frontiers still to explore. For every question we answer, a dozen new ones bloom in its place. Will we ever find a rogue planet with a hidden ocean? Will we ever capture a particle of dark matter? What other bizarre stellar remnants are waiting to be found? These questions are the fuel for science, the inspiration for the next generation of explorers who will look up at the sky and wonder, what's out there? They are the reason we send messages in bottles out into the cosmic ocean. So the next time you look up at the night sky, remember that you are not just looking at twinkling points of light. You are looking into the largest and most wonderful museum of curiosities that exists. You are staring into an abyss of unending mystery filled with objects that defy belief. The story of the universe is the greatest story ever told, and we have only just read the first page. Stay curious, keep asking questions, and never lose that sense of wonder. Because the strangest thing in space might be something we haven't even discovered yet, waiting for us just beyond the edge of our current knowledge.